Here's a podcast on moles, and we're going to do grams to moles to atoms with individual atoms, and we're also going to do it with compounds, which would be molecules. So we're going to do some grams to moles to atoms. And these would be individual atoms. For example, just atoms like iron or sodium or magnesium. Notice that these are just one atom, one thing. So you can go grams to moles to atoms, or we could go backwards, atoms to moles to grams. And you would flip everything. If you went atoms to moles to grams, you would flip the fractions. We're going to take an example of 2.00 grams of gold. Who doesn't like gold? It's shiny and yellow. And we're going to change it into moles first. So to go grams to moles, we will divide by the molar mass. And this is from worksheet 2 if you have access to those worksheets. So 1 mole of gold. You then need to go to your periodic table or your list of masses, and you'll find gold on here. And gold is about 196.97 grams. And notice that the grams of AU are on the top when we start, and then we write them down as grams AU on the bottom, and they're going to cross out. And we do 2 divided by 196.97 because it's as if we had 2 over 1. And then when we do this in our calculator, we get about 0.0102. We have 3 sig figs there because we started with 3 significant digits, and the 3 digits that count are the 1, the 0, and the 2. Those first 2 zeros are leading zeros and they don't count. So that's if you want to go grams to moles. And we just stop at moles. We hit equals there. And now we're going to do one backwards, which is moles to grams. And this is from the worksheet that exists in some parallel universe. And so let's say we had 2 moles of iron, which is Fe. I like to call it Phi. And we want to get rid of moles, so we'll put moles on the bottom because it's on the bottom but kind of shifted over 1 to the right. And next to mole we always have the number 1, so 1 mole of Fe. And to get the grams on the top, we go again to the periodic table and we look up our friend Phi. And Phi is about 55.85 grams. And since these 2 numbers are next to each other, we multiply them together. And we do have 3 sig figs because we started with 3 digits, 1, 2, 3, and we'll end with 3, 1, 2, 3, so 112 grams of iron. Now we're going to do the full thing for just individual atoms. We're going to do grams to moles to atoms. And these will be our units on the tops of our fractions. And this is number 13 from worksheet 1. So we have 0.001003, I got it all mixed up, potassium, and we're going to get rid of our grams. And so 1 mole of potassium has so many grams, so notice the grams here are, one's on top, one's on the bottom, so they cross cancel, and potassium is about 39.10 grams. One more fraction here. So we did a step from grams to moles. There's our grams and our moles. And then our next step is moles to atoms. Notice that those are the units on top. So 1 mole of potassium has 6.02 or 6.022 e to the 23. And that e on your calculator is really the capital E. Use the second button, second function button, and the comma above the number 7. And notice the moles of K and moles of K are opposite, so they cancel out. So you do this number divided by that times that. 3 digits that count, 1.59 times 10 to the 19th atoms of K. That's a lot of atoms. I don't think I could count them all. Do you? Let's fast forward here. You like all my canceling out. So now we're going to do atoms to moles to grams. It's the reverse. Teachers love to ask the reverse question on a test. So if I were to give you question number 15 from some magical worksheet in some magical universe, 1.5 E times 10, that E means times 10, atoms of carbon. I like carbon. And we got to get rid of these atoms of carbon, so we'll repeat them on the bottom. And then our next unit on top, so notice atoms go there, the moles are going to go there, and then grams are going to be in the last fraction. So we'll put moles on the top, and the number always next to mole is 1. So 1 mole of carbon has so many atoms. In fact, it has Avogadro's worth of atoms, 6.022 E23. Now we got to move to the next fraction. 1 mole of carbon is 12.01 grams of carbon. We do this number divided by 6.02 times 12.01. We have only 2 sig figs, so 3.0 times 10 to the second if you're being fancy, or 300 with a dot at the end, or 300 with a line over it, grams of carbon. Let's move along. Now molecules, this is totally different. It's similar, but it's different. So we're going to do grams to moles like we have before. Then we're going to do moles to molecules. Molecules is a fancy word for compounds. And then we'll break that compound down into atoms. And I abbreviate molecule as M-O-L-E-C. Notice it is not the same as mole. And we could do the reverse, atoms to molecules to moles to grams. And sometimes I call it GMMA. Good morning, Miss America. And if you do the reverse, your fractions flip-flop, and that's at the beginning, and then that's at the end. So let's try a problem. So we have 25 grams of H2O, water. So we're just going to go to atoms here. So grams of water, we repeat it on the bottom so it cancels out. It's kind of our little practice friend. And on top goes mole. Next to mole is always 1. And then we repeat mole on the bottom, so 1 mole of water. And then up here, if you had 1 mole of water, you have that many molecules. It's not atoms because it's a compound. And you could use 6.022 also. And then we repeat molecule. Molecule, when it's with moles, has Avogadro's number. But when molecule is with atoms, atoms will be up here, the molecule is 1. And we have to look at what the question is asking. So this particular question, even though it's not written down here, says how many atoms total. So if you add up 2 hydrogens and 1 oxygen, you get 3 atoms. So you do 25 divided by 18 times Avogadro's number times 3. And you get a number, and your final answer will have to have 3 sig figs, so 2.51 times 10 to the magic 24 atoms total in 25 grams of water. That's a lot of atoms. Now we're going to do the reverse. Atoms to molecules to moles to grams. You always have to follow that pattern. You can't skip a step. So if you had 505 atoms of CO2, and this must be asking about that you have 505 atoms of CO2 total, and it's probably asking you what the mass of the CO2 is if you have that many atoms. So that 3 came from 1 C and 2 O's. So there's 3 atoms in CO2 for 1 molecule of CO2. Here we repeat molecule. We put mole on top. With mole and molecule, it's always 1 for the mole. Molecule's Avogadro's number. And then here we pretty much repeat the 1 mole of carbon dioxide down there so we can cross it out. And we write the grams of CO2, which is about 44 grams. We do 505 divided by 3 divided by Avogadro's number times 44. And we should get a happy number. Aren't all numbers happy? Maybe 0 is not happy. 1.23 times 10 to the minus 20th grams of carbon dioxide. Wow, that is tiny. I don't have a scale to weigh that amount. I think that's all we have for the grams to moles to atoms. So we did grams to moles to atoms for individual things. That's talking just one thing. And that's if you're single. But if you're married or have a partner, you have to do grams to moles, molecules to atoms. The molecules like the family. You have to break it down from the whole family into the individual parts. Like CO2, H2O, NaCl. I hope this was helpful. I will see you sometime in the future.